Let's first revise the things that we learned in last class. Okay, now I will ask the questions, you will answer. Okay, let me name this triangle.
Okay.
Let me name this triangle as triangle PQR. Okay, now tell me
Yes.
sine ratio, sine of this theta, sine theta.
Opposite upon hypotenuse.
Okay, opposite side upon hypotenuse. Okay, tell me opposite side of theta. Which side is opposite to theta?
PQ.
Where is PQ? See, the theta is this one. This is the theta.
Yes.
Then
Yes.
according to this theta, tell me opposite side and
Yes.
hypotenuse. Tell me now then.
Hypotenuse is PR.
Hypotenuse is PR.
Uh, and opposite is PQ.
Opposite is PQ. So you mean ki this is the angle and its opposite side is this one. PQ. This is the PQ. And you are saying ki this will be adjacent side QR.
Uh, no,
अगं
QR will be.
अगं तू थीटा काय आहे तू पाहिलं का पहिला. This is the theta. I have marked it blue. With
Oh,
respect to
angle
this,
P.
yes, with respect to this theta, what is opposite side of theta? Which is opposite side of theta?
QR.
QR, right. Every time it is not necessary that they will take theta is equal to this angle only, which is rounded. Every time this may not be
Yes.
theta, na? This time this is 90 minus theta, 90 degree
Yes.
minus theta. Getting it?
Yes. Yes.
Hmm. Okay. So tell me now cos theta. Hmm. Sin theta is opposite
Cos
side
theta adjacent
of
upon hypotenuse.
QR upon PR. Okay. Cos theta adjacent side upon hypotenuse. Hmm. Then it is, tell me in terms of sides of this triangle
Yes.
PQR. Hmm. Tell me
Hmm.
these terms. क्या
Adjacent
terms?
side is
हाँ.
ad- adjacent side is PQ upon PR.
PQ upon hypotenuse PR. Very good. Cosec theta.
Cosec theta is 1 upon sin theta. So hypotenuse upon opposite.
1 upon sin theta. So hypotenuse upon opposite side.
Upon opposite.
Hmm. Now tell me according to
Yes.
this triangle. Tell me this ratio according to this triangle.
PR upon QR.
PR upon
PR
QR.
upon QR.
Okay, that's great. Very good. Okay. Cot
QR.
theta. Last ratio cos theta. Cot theta. Tell me directly now, according to this triangle, tell me what will be cot
Cot
theta ratio.
theta is 1.
Hmm.
Cot theta will be 1 upon tan theta. So
Hmm.
adjacent upon opposite.
Hmm. Hmm.
Uh, Adjacent is PQ
Hmm.
and opposite is QR.
PQ upon QR. Very good. Great. Now you have learned all these ratios. What is sine theta? What is cos theta? What is tan theta? Right? Okay. Now let me mark this another angle as 90 degree minus theta. Getting it?
Yes.
Okay. So this angle R is say 90 minus theta. 90 minus theta. Okay. Now tell me sine of 90 minus theta. Tell me this ratio.
I have to tell sine 90 minus theta. Okay.
Ah, yes, you have to tell.
Hypo,
Hmm.
sine theta opposite upon hypotenuse.
Hmm.
So hypotenuse will be PR and
Hypotenuse will be PR. Hmm.
opposite will be QR. No,
Why
no, not Q.
QR?
It will change, no? So
Yes, angle has changed, so opposite side of that angle will also change. This time
yeah,
this
so it
90
will
minus
be
theta is
PQ.
okay, it will be PQ. Very good. Okay. Tell me sec theta. Sec 90 minus theta. This ratio.
Sec theta is equal to 1 upon cos theta.
Hmm.
So hypotenuse upon adjacent.
Hmm. Hypotenuse.
Hypotenuse is PR.
Hmm.
And now adjacent will be QR.
Adjacent will be QR. Very good. Great. Going good. Okay. Now, next. Uh, what? Cosec of 90 minus theta.
Cosec is 1 upon sine theta. So
Hmm.
hypotenuse upon opposite side.
Hmm.
Hypotenuse is PR
Hmm.
and opposite, no, we want.
Hmm. Opposite one.
Opposite is PQ.
PQ. Very good. Great. Okay. So this way you will find various ratios, sine, cos, tan, cosec, sec, cot of theta. Right? There is no difficulty,
Yes.
there is no doubt now. Okay. Now, as I already told you that trigonometry is all about measurements of right angle triangle. Okay, so let's say this is the triangle ABC, right angled at B. Okay, now
Yes.
apply Pythagoras theorem to this. Hmm. Apply Pythagoras theorem to this right angle.
Hypotenuse square is equal to perpendicular square plus base square.
Okay, hypotenuse square is equals to perpendicular square
Upon base square. Or plus base square.
plus base square. Okay. Now, according to this triangle, what is hypotenuse
AC
for this triangle?
square.
AC square is equals to
AB square plus BC square.
AB square plus BC square. Okay. Now I am marking this equation as one. Okay. Now, will it help you to find that three basic trigonometric identities, and how Pythagoras theorem is going to help you in finding that three basic trigonometric identities?
Yes, when two values of an triangle is given, we
Hmm.
can find the third value.
Okay, in it, Pythagoras theorem is used where two values are given and third it needs to be found. Okay, now my question is I wanted to construct identity for okay, that means the relation between various ratios of that trigonometric ratios, sine, cos, tan, cot. Okay, for that I want to construct identities. So can Pythagoras theorem be useful for that? Can it be useful?
Yes, we have
Hmm.
to find
How?
the side it
Huh.
is.
Okay. What you have to find?
If a missing side is given, then we
Hmm.
can find by getting two values.
Okay. Missing side is given, then we can find it by getting two values. Okay. Now see, this is the equation one. Okay. Now I'm rewriting this equation again. So it is AB square plus BC square is equal to AC square. Okay. Is it okay?
Yes.
Now
Yes.
I am dividing both sides of this equation by AC square. Divide by AC square. Then I will get what? AB square upon AC square plus BC square upon AC square is equals to AC square upon AC square. So this AC square can cancel with this AC square and I will get 1. Okay. So it is AB upon AC square plus BC upon AC square is equals to 1. Now tell me what this ratio is according to this triangle. What is
Okay,
this
so we
ratio
have to
called?
tell in terms of sine and all
Ha, yes.
ratios.
What is this ratio? Is it cot?
A
Is it cosec? Ha. What this ratio is in trigonometry?
AB is
Hmm.
AC is hypotenuse in both the denominator,
Hmm. AC is
and AB
hypotenuse.
is adjacent.
Hmm. AB is adjacent here with respect to this theta I am talking about.
Okay, then in respect to theta, then AB is opposite.
Opposite side. Right? Now, then what
Yes,
this ratio will be called?
opposite upon hypotenuse.
Hmm. In
Sine.
trigonometry, sine theta, sine of theta. So instead of AB upon AC, let me write sine of theta. Okay, the bracket is there and square is there. Now I'm moving towards next term. It is the ratio BC upon AC. Okay. Now what this ratio is in trigonometry? What
Cos
is it?
theta.
Right? How?
Adjacent upon hypotenuse.
Adjacent upon hypotenuse. So it is nothing but the cos theta. So here I am writing in place of BC upon AC as a cos theta and its square is there. Now instead of writing the square like in the bracket, let me write like sine square theta plus cos
Cos square
square
theta.
theta is equal to 1. So this is my first fundamental trigonometric identity. First identity. Okay. Can you construct the
Yes.
second identity from this equation? This I have constructed from this equation.
Okay.
Can you construct the second identity
Tan square
or
theta plus x square theta.
tan square theta plus sec square theta? Is it the second one?
Plus 1.
Plus 1. Is this an identity?
Yes.
Yes, it is the identity. Have you
Yes.
forgotten or what?
We have written the three identities, no? Sine
What was the
square
first
theta.
identity?
1 is equal to sine
Hmm.
square theta plus cos square theta.
Sine square theta plus cos square theta. This was first identity.
Uh,
Second,
then 1 is equal to tan square theta plus sec square theta.
who formed this identity? 1 is equal to tan square theta plus sec square theta. Who said this? Let us check whether it is correct or not. Okay. Let's say this is the right angle triangle. This angle is say theta. Okay. Is A, B, and C. Okay. What this tan square theta plus sec square theta is? Let us check. Okay. Now for this triangle, tan theta is what? Opposite side upon adjacent side. AB upon BC square plus sec theta means what? 1 upon cos theta. So adjacent side BC upon AC square. How this come equal to 1? How? It is not correct. That's not an identity even.
Okay.
You just thought there is sine square plus cos square. That's why there might be tan square plus sec square and then might be cosec square plus sec square, right? Was this your
Yes.
thought process?
Yes, like we wrote no three identities.
Three identities we wrote like, but what was that identities? What were that? Just see and tell me.
I have written 1 is
Hmm,
equal to sine square theta plus cos square theta.
very correct.
Then 1 is equal to tan square theta plus sec square theta. And then 1 plus
That you
cot square
wrote.
theta.
Who told you 1 is equal to tan square theta plus x square theta? Who told you this?
I wrote it on
Wrote
that
it.
date.
No. That's not an identity. That is wrong. Please mark
Okay.
it incorrect. Okay. Now let me tell
Okay.
you how that second identity is constructed. See here. See, what we did here to construct first identity, what we just did.
We divided by AC.
We
We divided by
divided by
hypotenuse.
AC square. What? Not by AC, we divided by AC square. See here, divided by AC square. Right?
Yes.
Okay. Now, in place of AC square, by which number you can divide it?
Huh?
What will happen if I divide this equation 1 by AB square? AB square ne
If we
divide
divide by
किया.
AB square, we'll get a new
Then
identity.
okay, then what will be that? Tell me the steps. What should I write here?
First, AB square
AB square
uh,
plus
plus BC square
BC square
is equal to AC square.
is equal to AC square. Divide by
AB square.
then AB square upon AB
AB
square,
square
BC square
upon
upon
AC square.
AB square, AC square
Uh,
upon AB square.
AB square.
Then what will happen in the next step?
AB square and AB square will be cancelled.
Okay, then what else will be remaining here?
BC square upon AB square.
What should I write here? It is correct.
1.
B 1 and BC upon AB. Can I write this bracket square?
Yes.
Okay, then next AC upon AB. Can I write like it's common square?
Yes.
Okay. Now tell me what this BC upon AB is. What is it?
Cot theta.
Cot theta.
Adjacent upon opposite.
Think before answering. Think properly and then answer. Don't be hurry for answers.
1 upon tan theta.
Is it 1 upon tan theta?
No, 1 upon tan theta will get cot theta, no?
Huh.
Huh.
What this ratio
Adjacent
is called in trigonometry, BC upon AB.
cot theta.
Cot theta.
Yes.
अरे आय सेड की थोडस विचार कर आणि मग आन्सर कर. बघ चेक कर इथं ह्या ट्रायंगल आहे याचा बीसी आहे
Huh.
हा एसी आहे हा बीसी ए बी आहे हा ठीक आहे. सो बीसी डिवायडेड बाय ए बी मीन्स दिस साइड डिवायडेड बाय दिस साइड बीसी अपॉन
Huh.
ए बी or this theta what this ratio will be called in trigonometry. Got my question now?
Yes, adjacent upon opposite.
Adjacent side upon opposite side, right? And what is this ratio? Adjacent side upon opposite side. What this that ratio is?
Cot, no?
Adjacent upon opposite.
Tan theta is opposite upon hypotenuse, then cot theta will be different. Hypotenuse upon opposite.
Okay, so BC upon AB, you are saying it will be cot theta. Okay, then what this ratio will be?
AB will be our adjacent side.
AB is adjacent here.
AB is opposite side.
Hmm.
Uh,
Hmm. What? What this ratio is called? AC upon AB.
hypotenuse upon opposite cosec theta.
Cosec theta. Cosec theta. Okay. So in place of
Yes.
this, this is 1, no doubt. Okay, this is 1 plus BC upon AB. In place of it, I can write like cot square theta is equal to, in place of AC upon AB, I can write like cosec square theta. So this is this third identity that is formed. Third or second, you can call it as, the number is not important, identity number. Okay, so this is one of the identities formed. Okay, this is actually third identity. The second is when you divide by BC square. Now divide by BC square and form the next identity. Again, divide this equation only. Equation 1 by
Will divide by BC square.
BC square. Then it will be AC upon BC, right? Square
Yes.
equals to AB upon BC square plus BC upon BC square. Then it will be like BC upon AC upon BC. What this ratio is?
AC upon BC is 1 upon cos theta sec theta.
So it is sec theta and its square, sec square theta. BC upon BC.
AB upon BC.
AB upon BC.
AB upon BC tan theta.
Tan theta, very good. Tan square theta. So this is the second identity that you got. Second identity. First identity is sin square theta plus cos square theta is equal to 1. Second identity is 1 plus tan square theta is equal to sec square theta. And third identity 1 plus cot square theta is equal to cosec square theta. Okay. So you wrote this first identity. On that day we have seen this identity. Now you write down this by writing this like divide both sides by BC square. Write the second identity and then third identity. Write it down now.
Yeah, I wrote all the three identities.
All the three identities you wrote. Okay. And what about that identities that you wrote previously? We tan square theta plus cot square theta, sec square theta plus cosec square theta. Was that an identity?
Yes, if we change their places, it is an identity, no?
What? We change the places.
Now sec square theta is equal to 1 plus tan square theta.
Right. That is an identity, huh?
Then we can't write 1 plus tan square theta is equal to sec square theta.
Yes, we can write like 1 plus tan square theta is equal to sec square theta.
Then I've written that only.
Yes, right, that is correct. But previously you told me that you have written like tan square theta plus cot square theta is equal to 1. Sec square theta plus cosec square theta.
No, I said 1 plus tan square theta plus sec square theta.
Acha, sec plus tan, na? 1 plus tan square theta plus sec square theta is equal to 1. That you told me. Okay.
And third, I told 1 plus cot square theta is equal to cosec square theta.
Now you told me. Previously it was like
no, previously also I told that only.
1 plus
1 plus
square
cot square theta. is equal to cosec square theta.
So we have second identity 1 plus cot square theta is equal to cosec square theta, and 1 plus tan square theta equal to sec square theta. So those are the three basic fundamental trigonometric identities. That is correct. That is also correct. Okay. Now these are the identities that we are going to use to simplify the trigonometric functions. That is the one thing. Okay. Getting my point?
Yes.
Okay. Now let's go ahead. Let's move towards next section. Okay. So that identity wala part is done. Okay. So let's take few examples from textbook. Hmm. Okay. Now let's construct a table for standard angles, ratios of standard angles of right angle triangle. Okay. Let's say if this angle is 60 degree, this is 90 degree angle, right? Then this will be how much?
Hmm.
It will be 90 minus
And
theta. That is 90 minus 60 degree. It will be 30 degree. So this angle is of 30 degree. Angle A, B, C. Okay, getting it. And there is one more triangle.
yes,
There is one more triangle which is isosceles triangle. Let's say this side is equal to this side and this angle is 90 degree. Then here if it is theta, then it will be 90 minus theta, and then that will be again theta only. Okay. So in this theta will be of 45 degree measure, and this will be also of 45 degree measure. Okay. So now we are going to write down ratios of trigonometry for some standard angles. Okay, understood.
yes.
Okay, what are the standard angles? Some standard angles are 0 degree,
0 degree, 30 degree,
30 degree,
45
45
degree,
degree, 60
60 degree,
degree, 90 degree.
90 degree.
Okay, then these are the ratios: sine, cos,
Cos,
tan,
tan,
cosec,
cosine,
sec,
sec, cot.
and cot. Or you can write like tan cot sec, tan cos tan, cos sec, cosec, cosec. That way also you can write it down. Okay. Now I just wanted to know what are the values of trigonometric ratios of the standard angles. Getting it? I just
Yes,
wanted to find the values of ratios of the standard angles. Okay. Now what I will do is I will write 0, 1, 2, 3, 4. Okay. Now I will divide each of these number by 4. Each of these number by 4. Okay. And then after simplifying, I will get it 0, 0. It is 1 by 4. It is 1 by 2. It is 3 upon 4. And it is 1. Now let me take square roots of it. Okay. I have taken square roots of it. So it is 0, 1 upon root 2, 1 upon 2, because square root of 4 is 2 only, no? 1 upon 2 only, 1 upon 2, 1 upon root 2, root 3 upon 2, and 1. Okay. So these are the values obtained after dividing numbers from 0 to 4 by 4 and by taking square roots. Okay. Now write these numbers as it is here in the first row. 0, 1 by 2, 1 upon root 2, root 3 upon 2, and 1. Okay. And then reverse. Now go reverse way. 1, root 3 by 2, 1 by root 2, 1 upon 2, 0. Okay. Now to find out tan ratio, to find the tan ratio, divide sine ratio divided by cos ratio, then you will get like 0 upon